Understanding GPU pins of Raspberry Pi. Uses of GPU pins. In the previous sessions on Arduino Uno, ESP32 Node MCU, we have seen the GPU pins on those evaluation boards used to control the external hardware. GPU pins are very powerful as their functionality is just not restricted to allocated protocols. For example, a GPU pin can be used as an I2C line or an SPA line or an UART line. The protocol can be mimicked by using a GPU pin and data can be sent without having the pin to be configured. This technique is called bit banging and it can be achieved with any GPU pin. But generally, these GPU pins are used to either send or read voltages from external hardware. You can see a simple representation presented in front of you where Arduino both reading and writing using the IO pins at the same time. Understanding GPU pins better. The adjacent picture shows the numbering and the detailed functionality of each GPU pin on the Raspberry Pi board. Facing the Ethernet port towards you, the numbering of the pin starts from the top left and continues till 40 as shown in the figure. Raspberry Pi offers 3.3 and 5 volt power output because many sensors might have different operating voltages. It also has many ground pins. Raspberry Pi also comes with native UART pins at 8 and 10. It also has PWM, SPI, I2C and PCM peripherals which are enough for most of the projects. PCM is a protocol which is widely used in high quality sound generation applications. Digital to analog converters are used to generate a sampled analog sound signal. The pins allocated to I2C, SPA or UART will work according to their functionality only when it is switched on in the Raspberry Pi config, or else they will work as a normal GPU pin. For example, the physical pins 8 and 10 of Raspberry Pi can either act as default UART or as GPU pins 14 and 15. This is a very important point to remember and make sure you understand this pretty clearly. For them to work as UART, you need to go to Raspberry config and switch on the serial functionality, or else they continue to work as GPU pins only. Similar is the case for I2C, SPA and PCM. And you could see the representations that we have given in terms of pin diagram in the right hand side, and the Raspberry config is presented here, where you can see that you can enable and disable as per your requirement. Kindly note that the Raspberry Pi board does not offer any analog GPU pin, so you cannot directly connect any analog sensor to read the data from it. Possible solutions for this are available as well, and use an analog to digital converter available in the market. This is a good method to read the analog values. Connect the analog sensor to any evaluation board which supports analog GPU pins like Arduino Uno, Arduino Nano, ATtiny, etc. Code the evaluation boards such that it prints the analog data on its serial and connect the evaluation board to Raspberry Pi using an USB or UART. Use an evaluation board which supports analog GPU pins and Wi-Fi which can be like Node MCU or ESP32, and then upload the data to the cloud. Write a simple Python script which can read the data from the cloud. It gives accurate analog values but requires a lot of resources, and the data cannot be obtained continuously as we can upload at most one data point per 1 second. Use an RC charging circuit. Most frugal method, but this is less accurate. If you want to get more information about the ADC method, please visit the link that is presented in front of you for quicker reference. If you visit this link, you can get more detail about the analog to digital conversion methods. Connection diagram. In this session, we will understand the GPU pins of Raspberry Pi by blinking and changing the brightness of LED. We are using Raspberry Pi 4B with 4 GB RAM, and you can use any version above Raspberry Pi 2 as all of them have similar GPU configurations. Please remember to connect the LED to a PWM pin as we are changing the brightness of an LED. To be extra cautious, please have a resistor connected between LED and Raspberry Pi. Kindly follow the connection details that we have prescribed in the table, as well as the same is presented as a connection diagram. It is must to follow this correctly so that you get the output as expected. Installation of required software. Before you start coding, check if you have installed all the required software in the system. For the exercises in this course, we need the software Python 3 and idle. For checking whether Python 3 is installed, please go to the terminal and type Python 3. If you get Python interpreter, then Python is installed and it is all set. Similarly, idle 3 in the terminal to check whether idle is installed or not can be issued. If Python is not installed, then issue the command sudo apt-get install python 3 to install Python 3. And if you want to install idle, then type sudo apt-get install idle 3. This should be working fine and you should get it installed immediately. And we have presented the command as screenshot for your quicker reference. Let's code it. Initially, RPA.GPIO and time libraries are imported. These libraries are installed while installation of Python, but in case if these libraries are not installed, then go to the terminal and install using pip. RPA.GPIO is imported as GPIO, which means that you need not type RPA.GPIO for every command. Instead, you can just type GPIO. GPIO.setMode with option GPIO.BCM is used for numbering the pins according to their GPIO pin numbers, while GPIO.setMode GPIO.board is used for numbering the pins according to physical pin number. For an instance, the physical pin 32 is the GPIO pin 12. So, if you use GPIO.BCM, then you need to declare the LED pin as 12. But if you use GPIO.board, then you need to declare LED pin as 32. GPIO.setup is used for setting the direction of operation of a pin. It is similar to pin mode in Arduino IDE. As we need to control the LED, we will set the direction as GPIO.out. This code is for blinking the LED. Try except block in Python is used for trying a piece of code, but if an interrupt occurs in between, then another piece of code gets executed. The code written inside finally block is used for executing after the try except block. In the try block, we will blink the LED indefinitely, while one is used for running a code inside indefinitely. GPIO.output is used for digitally writing voltages on the pin. It is similar to digital write in Arduino IDE. GPIO.output takes two arguments, that is the pin number and the digital voltage to be written. True is treated as 5 volts and false is treated as 0 volts. Time.sleep is used for pausing the program and it is similar to the delay in the Arduino IDE. But time.sleep takes time in seconds and not in milliseconds. This is an important point to be remembered. The code snippet is presented in front of you for a quicker reference. Except block has the code to be executed when an error or interrupt occurs while running the try block. As we have a try block which runs indefinitely, the only way to stop is by using keyboard interrupt. We can generate a keyboard interrupt by pressing Ctrl+C on the keyboard. So when the keyboard interrupt occurs, then the except block runs. Here we print blink code is stopped. The code in finally block is run when the try except block completes execution. While the LED is blinking using the GPIO12, Raspberry Pi allocates the GPIO12 resources to the blinking task. Even if we issue a keyboard interrupt and stop the code, the resources will still remain allocated. So we need to detach the resource allocation using GPIO.cleanup command. If we do not use GPIO.cleanup while exiting the code, then we will get a runtime warning as you are seeing in front of you. Please go through the small code snippet that is presented in this page for you to understand all this clearly. This talks about the keyboard interrupt and then the finally block. This code is for changing the brightness of an LED. GPIO.pwm is used for setting the frequency of a PWM pin of Raspberry Pi. It accepts two arguments, pin number and frequency. LED pin is GPIO12 and frequency is set to 500 Hz. The theory behind PWM pins and its operation are all clearly explained in beginner's course. The code shown below is also very much similar to the one we used in the brightness control of LED in beginner's course. Duty cycle is used for controlling the brightness. Initially it is set to 0 and then it is gradually increased by 5. Change duty cycle is similar to the function analog write in Arduino IDE. It is used for changing the duty cycle of the PWM pin. For every step, a time delay of 100 milliseconds is given. Kindly remember, analog write has got nothing to do with analog pins or analog read, and both are different from each other. The code snippet is presented for your easier understanding and quicker reference. In this exercise, we will understand how do we blink the LED using Raspberry Pi. Also, we will understand controlling the brightness of an LED using Raspberry Pi. Also, towards the end of the session, we will understand how do we transfer file from the PC to Raspberry Pi and Raspberry Pi to PC in a neat way. We are going to follow step-by-step guidelines and we request you to observe it. You can follow the same guidelines to get this process completed. You can see the connections here. We have used the LED and it is connected to the Raspberry Pi along with the resistor, and GPIO pins are used for the connection purpose. Please follow the guidelines and get it done the same way that we have done. Now open the VNC viewer and click on the IP address corresponding to your Raspberry Pi, and you can double click it to get it opened. The moment you get it opened, you are into the Raspberry Pi and we are going to work with Raspberry Pi right now. We will have to check certain things like if the libraries are installed, if Python is installed properly, and that's what we are going to do right now. We will go ahead with the terminal and we will check all these primary installations which are to be completed properly. To check if Python is already installed, type Python. If it had been already installed, you would get the prompt as you are getting right on the screen. You can type exit to come out of it. Now we need to see if Python 3 is also installed properly. If yes, you would get the prompt displayed on the screen and you can exit if things are proper. Next, if you want to work on the same environment of Python as we worked in Windows, we need to install idle. This step is completely optional and you can edit and run the Python files using the nano editor as well. Sudo apt get install idle3. This is the idle that we have been using in Windows. It is not available by default in Raspberry Pi. So we have to install it using the command that I flashed on the screen. Once you install it, you would get the idle3 available for you to use under the programming pane as Python 3 idle. Now when you click it, you will get the idle3 open for you right in front of you. The Python shell is all available for you and it's all yours right now for you to use. Go to file and click new file for opening a new file, and you can type your content here and you can run and compile it. This is as exactly what we use in the Windows platform and it is very similar to it. The next step is very important too, and we are going to go ahead and install one more library. We are going to check and see if things are properly installed as we have been doing, and this time it is for rpi.gpio. We are doing a pip install rpa.gpio, and if it has been already installed properly, you would get the message as you are seeing in front of you, but otherwise it will install it properly right now. The requirement is already met and hence it has not been done again. Now it is time for us to understand how do we send and receive files from to Raspberry Pi. We have got a couple of files that are created in my PC and you can see the files in the desktop. We need to click the icon. As you can see, transfer files, and once you click that, you will get send files option. Click that and it will take you to your PC and you can select the files location properly. Since my files are in desktop, I am selecting the two files and I am clicking open. The moment you do that, the process is almost done and sending files will be now done, and you can see both the files available in Raspberry Pi right now. Now we are going to send the file from Raspberry Pi to your PC. For that, we need to create a file. We are creating a new file by name newfile.txt and we are going to send it across to the PC. So for that, we need to open the VNC from Raspberry Pi. We are clicking it here and you can see that there are a 3 bar option available, 3 lines are available. Click that and in that there is a file transfer option available. Send files have to be clicked and you can search the file that you want to send it to the PC. I am going to the desktop of my Raspberry Pi where you can see the newfile.txt being available. I can select that and clicking OK will get me the file transfer complete. Now we can check if the same file is available in the desktop of my PC. Yes, it has been available and the copy is complete. Now it is time for us to see the demo. We are going to check if the blink LED and the brightness control are going to work properly. For that, the connections are to be made and we have already explained. Now we need to open this file blinkled.py. And let's enlarge it a little bit and go to run, and run module will get you the file running. You can see that the LED is flickering fine and this code is working fine. And for us to come out of it, we need to give a keyboard interrupt, and that's nothing but Control C. When I give a Control C, the blink code gets stopped and you got a message on the screen as well. Now I'm going to load the second code. I'm going to run the second code, which is going to control the brightness by varying the brightness. We are going to enlarge the screen and we are going to run it. Run module gets it running, and you can see that the LED brightness is comfortably controlled and it's going high and low. It varies properly, and that is how the code can work. And giving a Control C would stop the process. And here we have understood how exactly to control an LED's brightness, also how to flicker the LED through this demonstration. Let's summarize. In this session, you have learned the physical and GPIO pins on the Raspberry Pi. Various protocols supported by Raspberry Pi are also quickly discussed. LED is controlled by the GPIO pins of Raspberry Pi. Blinking an LED and changing the brightness of an LED are also done